Howdy and welcome back. I've now identified the points of trust in a traditional fiat banking system and mapped those points of trust to a model that will show the features necessary to implement transactions without trust via the Bitcoin protocol. Now, there may be better approaches to learning the Bitcoin protocol, but I've found that starting with the transaction is the most effective way to achieve maximum understanding. So Alice starts the process of transferring Bitcoin to Bob by using an application called a wallet to create a transaction. I've come to realize that what Alice is really doing when creating a transaction is documenting the transfer of control of Bitcoin, as opposed to a literal transfer of Bitcoin from one location to another. To better illustrate what I'm getting at, let's look at a simple overview of the process in a traditional banking transaction. In such a transaction, Alice could initiate a transfer of funds by writing a check from Bank A and giving the check to Bob. Bob, in turn, would then deposit the check into his account at Bank B. Bank B would then present the check for payment from Bank A. After validating the check, Bank A would reduce Alice's account balance by the amount of the check and transfer that amount to Bank B. Bank B would then increase Bob's account balance by the amount of the check. In a sense, the funds have traveled from Bank A to Bank B. As you'll soon see, a transfer of Bitcoin is different. Within the Bitcoin protocol, Bitcoins reside in transactions grouped together into blocks and something called a UTXO set. For now, you can think of a block as a collection of transactions and the UTXO set as a list of transactions that haven't been referenced yet. But I'm getting ahead of myself. All of the transactions ever made reside in a central database that's recreated and validated by each participant in the Bitcoin network. That's very different than the records kept separately by Bank A and Bank B. In the trusted system, participants rely upon these banks to validate the transfer and accurately record the debits and credits for each account holder. The Bitcoin protocol accomplishes the same task, however, with a very different implementation that requires no trust. Except for the Coinbase transaction, which I'll discuss later, transferring control of Bitcoin involves at least two separate transactions. The first transaction, called the current transaction, is created by Alice and more accurately, her wallet. The current transaction is just a collection of numbers that document Alice's intent to transfer control as well as her right to transfer control of some Bitcoin to Bob. In its current state, Alice's transaction is just a serialized piece of data. In computer science, serialization is the process of taking some data, in this case the contents of the transaction, and arranging it into an expected format. That is, the expected format is whatever the Bitcoin protocol expects. What's important to understand is that the transaction only has value after it's been broadcast to the Bitcoin network, validated, and becomes part of the live blockchain. In its current state, although the contents of the transaction encapsulates Alice's desire to transfer control of some of her Bitcoin, because it hasn't yet been broadcast and validated to the Bitcoin network, included in a block and that block added to the live Bitcoin blockchain, it doesn't have any value yet. As I'll show in upcoming videos, Alice can prove she has the right to pass control of Bitcoin to Bob based upon information only she possesses. And once transferred to Bob, only someone with his secret information can validly pass the right to transfer control of Bitcoin to someone else. Equally important, the current transaction contains some of the information necessary for Bob to use when he creates a subsequent transaction in the future. More on this in a moment. The second transaction, called the previous transaction, is a transaction that's already gone through the process of validation and admission into a valid block in the live blockchain. In addition, this transaction is also part of the UTXO set. Like the current transaction, the previous transaction contains information documenting a participant's intent to transfer control of Bitcoin to someone else. In order for Alice to transfer control of Bitcoin to Bob, her wallet must find previous transactions that contain enough Bitcoin to satisfy the current transaction. So the current transaction must contain at least one reference to a previous transaction that's greater than or equal to the amount Alice intends to transfer control over to Bob. Once Alice references the previous transaction and the current transaction is validated and included in a successfully mined block in the live blockchain, the previous transaction is removed from the UTXO set and considered spent. Therefore, the UTXO set contains all of the unreferenced and therefore unspent validated transactions in the system. So far, I've shown that transferring control of Bitcoin starts with creating a transaction. that the transfer of control consists of the current transaction and one or more referenced previous transactions, that each transaction documents participants' intent to transfer and right to transfer control of Bitcoin, and finally, the previous transaction is a transaction that's already been added to a validated block and successfully mined into the live blockchain, giving it value. The current transaction is simply serialized data without value until it too is added to a block and that block is successfully mined and part of the live blockchain. This is just the tip of the iceberg in relation to a transaction. I'll start exploring the implementation of identity within a transaction next. If you found this video helpful, please click the like button as well as the subscribe button. And thanks for watching.